Alright, so this is the third and the last video of questions related to base units. If you haven't seen the previous two videos, I'd suggest you go and see them first. This is the conclusion of that. So we are still continuing with the ideas of homogeneity and how they are tested by the examiner in different questions. So this is, in my opinion, like the more difficult or the most difficult questions that you have related to this, in which you are basically going to find unknown powers. So let me just write here, this is tier 3, level 3 of questions, and this is related to finding power of unknowns. Let's have a look at this question, summer 17, paper 1, question number 3. Let's make some space first. So, the speed V of a liquid leaving a tube depends on the change in pressure delta P and the density rho of the liquid. The speed is given by this equation, which is this. N is not known, K is a constant that has no units. What is the value of N? So we'll start with the same ideas. So V is speed, I know that's going to be meters per second. Density is also very straightforward, mass per unit volume, so that's kg per meter cube. But for pressure, I'll have to work this out if I do not remember it. And especially in paper 2 questions, you should work them out even if you do remember them. So pressure, force over area. Force is kg meter per second square. Area is meters square. When this denominator goes to the top, this becomes kg per meter per second square. And then you now start to work with the equation given. So let me use a different ink for this. So V is in meters per second, K is a constant that has no unit, so we'll just let this be. And on top you have kg per meter per second square, and then you have the density, which is kg per meter cube, and this is raised to the power n. So before going further, you need to simplify each of these sides. On the left hand side, there is no more simplification possible. Here these kg cancel out, and then you are left with the meter in the second square. When this goes up, this would become -1 minus -3, which makes this -1 plus 3, which is 2. So this becomes meter per second equals meter square per second square raised to the n. And this can then be written as m to the 2n s to the negative 2n. Now you can compare the powers of either m's or s. So here, let's say if I do this with m, so here the power is 1. So comparing powers here and here, so I would say 2n equals 1, which makes n to be half. So the answer to this one is A. Let's do another question. So this is the next question. The drag coefficient CD is a number with no units. It is used to compare the drag on different cars at different speeds. It is given by this equation, where F is drag force, rho is density, A is cross-sectional area, V is speed, and you are to find the value of N. Alright. So on the left hand side, CD, this has no units, right? So with the in the context of this question, if this has no units, and I will be using base units to talk about this, I can ignore this just as I would ignore this too. So if I ignore these, I can actually just rewrite my equation like this, right? Again, let me just go over this. CD has no units, 2 has no units. So in the context of base units, they are pretty much useless. So ignoring these two, I can write this as F equals to rho V to the N into A. And now I'll plug in my units. So F is force, so that's kg, mass and acceleration, so kg meter per second square. Rho is density, which is kg per meter cube. V is speed, which is meter per second, and this is raised to the power n, and area is meter square. Okay, just by the way, because some people ask me how does the units of density come about, so let me just write that here. Density is mass over volume, so mass is kg. The simplest volume formula, if you think about that, that would be a cube, and the formula for the volume of a cube is length cubed, and length is in meters, so that would become meter cube, and then we can write that as this. Anyway, let's come back to the question and try to solve this now. So this is kg meter per second square. Nothing happens here, and the trick to doing questions like these is to do things step by step and to use brackets so that you can clearly see where one quantity ends and the other one starts. And then opening up these powers, I'll apply these individually, making it this. This is that indices rule, where if you have like multiple variables raised to the same power, so the power can apply individually to each of these, and the meter square also remains as just the meter square. Now I'll scroll down. So on the left hand side, again, nothing happens. It's pretty much the same thing. On the right hand side, there's only 1 kg, so that remains as it is. If you look at the meters, so all of these are being multiplied, all of their powers would be added. So minus 3 plus n plus 2. So there is this n, and minus 3 plus 2 means this is minus 1, and s is raised to the power negative n. And now when no more simplification is possible, that's when I'll start comparing the powers. Obviously, it's no use to compare the kgs. I could do this with the meters, I could do this with the seconds, and this is left as an exercise for the viewer, that you can see that with both of these you'll get the same answer. Let's say for now I do this with the m's. So with the m, I would say that here the power is 1. So I would say that the power on the left is 1, the power on the right is n minus 1. So when this goes there, this becomes positive 1. So 1 plus 1, n is 2. Hence, the answer is B. Let's go on to the next question. Now we're getting the hang of these. The maximum theoretical power of a wind turbine is given by this equation. P equals to K rho A V to the N. Rho is density, A is area, V is speed, K is a constant with no unit. So again, we can ignore this. So it's just P equals to rho A V N. What is the value of N? So pretty much all are very basic except for power, for which you might need to derive this again, and that's not a problem. So power is work done over time, or energy over time, and work or energy both are given by kg meter square per second square. Time is given by seconds, so power becomes kg meter square per second cube. Now I have the left hand side of my equation as well, and now it's just time to plug in the base units for each of these. So this is kg meter square per second cube. On the right, K again, no need to write that down. Rho is density, so kg per meter cube. A is area, which is meter square. And this is V, which is meter per second raised to the power n. Right, so pretty much the same steps. Again, as long as you do one step at a time, you should be fine. So on the right, let me just first write these as it is, and then I apply the powers individually. So this becomes m to the n, s to the negative n, and you might have also noticed that rho a v n, so this is pretty much the same thing as what was there in the previous question. Kg remains kg. Again, m minus 3 plus 2 is minus 1, plus n makes it n minus 1, and this is s minus n. Again, it's totally up to you what you want to compare. Let's say that I want to compare my meters, right? So comparing meters, I would say that 2 equals n minus 1, taking this there and adding. So 1 plus 2, n is then equal to 3. Let's go on to the last question. So in this one, what's different is that there are two powers which are unknown, and we need to find the values of both of these. And it's not very different, as you'll see in a while. So frequency of vibration supported by a spring with a spring constant is given by this. C is a constant with no units. What are the values of P and Q? So frequency, if we remember, frequency is 1 over time, so that is 1 over seconds, which is s minus 1. And then similarly, the spring constant is force per unit extension. So that's kg meter per second square divided by meters. So that is kg per second square. And now I can actually start solving this. So on the left hand side, I have a per second. C is again a constant with no units. So I can just let this go. And then you have mass, which is m. So that is kg raised to the power p, and then k is spring constant, which is kg per second square raised to the q. So this is per second, again opening up the bracket. So this is kg raised to the power p, and then kg raised to the power q, and s raised to the power negative 2q. Again, I can simplify this a bit with the kgs. So s minus 1, this is kg p plus q, and there's only one s, so that is negative 2q. Now here you see some kg on the right, but there's no kg on the left. This means that there is a kg, but it has a power 0, right? So it's non-existent basically, right? So there's no kg, that means kg is raised to the power 0. So one equation I get by comparing the powers of kg, right? So comparing the powers of kg, I get p plus q equals 0, and I can say that p equals minus q. You can also say that. And then with the s's, you have minus 1 equals minus 2q. So from here, you get q as half. And then if q is half, so p is negative q, so that would be negative half. So p negative half, q is half, that means option B. So that's like the general type of questions you need to know when dealing with base units. We've done all of these in pretty good practice now, so you must have a good grip on this. So if you like this video, share this with your friends, comment if you had any problems or if you spotted an error, and do subscribe to the channel for more content like this that's going to help you revise at a glance what you find difficult in A-level or O-level physics. And I'll see you in the next video.